Assalamu alaikum, dear students. Welcome to the platform of Noor School and College Mansera for online classes of physics grade 12. Dear students, today we are going to discuss the transistor and its application in the field of electronics. First of all, I would like to tell you that the transistor is an electronic device which plays a very important role in the field of electronics. Transistor was actually designed in 1947 by a scientist named Berdeen. Berdeen received later the Nobel Prize for inventing this transistor. Now, if you realize the word transistor is extracted from two words, one is trans and zistor. Actually, this word transistor can be written as transfer of resistor. So trans from transfer and resistor from resistor, it makes transistor. Clear? So this transistor was invented, or it was devised or designed in 1947 with from by Berdeen, and later this Berdeen, along with his two companions, they got the Nobel Prize in physics for inventing the diode. When diode came into the market, this revolutionized the electronics. Now today, if you have a computer or laptop or your mobile phone, this is due to the transition, because the transition, as far as the transition is concerned, transition is considered to be the backbone of electronics. Now we are in the position to define transistor. What is transistor? The word transistor is taken from these two words, transfer of resistor. Trans from transfer and resistor from resistor. So this is the transfer of resistor. Now, but the actual definition of the transistor is this one, that transistor is a three-terminal semiconductor device. This is semiconductor device. As I have told you that semiconductor means it is made of diodes or silicon or germanium semiconductor. That is why it is electronic device. Transistor is a three-terminal semiconductor device which is used to control the current and to amplify the current. What do you mean by control? Control simply means to make it on or off, kind of like it is a switch. When you push the button on, the bulb is on. When you push the button off, the switch is off, and then the bulb is also off. This is called on or off state. So transistor is the three-terminal semiconductor device to control the current. From control, we know that there are two states. By control, we mean on and off. Similarly, the second performance of the transistor, or the second job of the transistor, is that it is used to amplify the current. What do you mean by amplify? Amplify simply means to step up or increase. Step up or increase, this is called amplify. To increase the value, to increase or amplify the value, what we do, we give input a small current and we get output as a large current. What does step up transformer do? We apply small voltage at input and we get large voltage at output. We call it step up transformer. In the same way, transistor does the same job. We apply a small current as input and we get as a large current as output. So again, transistor is the three-terminal device, semiconductor device, which is used to control the current or make it on off, and to increase or amplify the current. Give it a current input and get the current as output in the big quantity. Now, what is the principle of working? The principle of working, at what principle does the transistor work? Dear students, look here. The principle of working can be stated in this way. This is very interesting, and this is very important. You must remember this principle of working of the transistor, that we know that there are three terminals. For example, this is one terminal, this is second terminal, this is third terminal, terminal number 1, 2 and 3. Okay. Current in the third terminal is controlled by the voltage between first and second. Apply the voltage between first and second. Apply the voltage here between 1 and 2, and you will get the current I in the third one. Getting my point? The current in the third terminal is controlled by applying a voltage in the first and second. Look here. Current in the third terminal is controlled by the voltage between first and second terminals. Between first and second terminals, we apply voltage or a cell, and we get a current in the third, and the value of that current is controlled by changing the voltage between 1 and 2. This is simple. Okay. Now this is the schematic diagram of a transistor. It has three terminals. This is, for example, okay, let me tell you first, this is kind of like a sandwich. Sandwich means there is an n-type semiconductor in between two p-type semiconductors. What does it mean? Okay, I would like to tell you. Consider this page, for example. If I keep this page right here in between my palms or hands, you can see that this is this my right hand is p type, for example, and this left hand is also p type. And consider this paper. This paper is n side, so one n side is connected between two p sides. Getting my point? This is kind of like a sandwich. What do you do in when you make a sandwich? You take the two pieces of the bread and you take the egg in between these breads. This is kind of like, for example, this is p type, this is p type, this is n type. Another possibility is also available. If this is n side, this is n side, and center one is p side, but that will be considered later we'll discuss it. Okay, this when we connect the electric wires from these three terminals p and p, this is actually p, and this is called pnp transistor. Okay, one terminal is this one, it is first terminal. The second terminal is connected here, it is second terminal. And the third line or third wire or third terminal is this one. I showed you, this is 1, this is 2, this is 3. This is 1, 2 and 3. Okay. The first terminal is called emitter. This is called emitter. What is the function of emitter? We apply input. Here we apply input. We control from this point and we get collector as the output. This is emitter. The leftmost side of the transistor is called emitter. The central one is called base, and the right one or the third terminal is called collector. We apply input at the left side at emitter. We control it from the base and we get the output at a collector. So keep in mind, this side is E, center one is B, and this side is C. E for emitter, B for base, C for collector. Look again, E for emitter, B for base, C for collector. This is first terminal, second terminal, third terminal. Emitter, base, collector. We apply input at first terminal, we control it from the second terminal or base, and we get output at the collector. Okay, now you can see here, emitter is input, base is control, and collector is output. What does it mean? It means that we apply input at the emitter, we control from the base, and we collect at output. Okay, let me give you an example. Consider this water tap, pani ka nal ka water tap. Here the water comes input as input. When the water enters into the tap, here we get the output. Getting my point? From where do we control the amount of output? Right from here. We turn it and we reduce or increase the amount of water. Getting my point? So this input is emitter, this tap turning is base, and output we get at collector. Clear? In the same manner, we apply input at emitter, we control it from base, and we get output at the collector. This is first, second, and third terminal. First one is called, leftmost is called emitter, center one is base, and this right one is collector. Okay, now symbol. As far as the electronic symbol of the transistor is concerned, this is the symbol. You can see that in this circle the symbol is shown. One central line, one oblique line, this is the second oblique line. You have to be careful about the direction of the arrow. You can see that here the direction of the arrow is inward. The arrow is inward. If the arrow is inward, it is PNP transistor. This should be remembered. Okay, one terminal is this one, second terminal is this one, and third one is this. As we know that the leftmost terminal is emitter. For reference, look here. The leftmost terminal is emitter. The central one is base. So here this one is the base. The right one is the collector. So this one is the collector. Clear? Now here it is written voltage is applied here in between E and B, between these 2 points, or you can say that between emitter and base, because base is connected here and base is also connected here. So between E and B we apply the voltage and we get the current right here. Current is controlled here. We apply voltage here and we control the current here. We get the current at C. This is the basic function or performance of the transistor. In the same way, this was, dear students, PNP transistor. Now I would like to tell you NPN transistor. You can see that this is NPN transistor. In the previous slide you saw that this was PN and P transistor, but now we are considering NPN transistor. Basically there is no difference between PNP and NPN transistor. The only difference is that in PNP transistor, N type is sandwiched in between two P types. Here in NPN transistor, one P type is sandwiched in between two N type semiconductors. The same thing is applicable here. The left one is emitter, this one is base, the central connection, and the rightmost connection is collector. We apply input at the right hand side and we get output at the right hand side at collector. Input is always applied at the left side, it is emitter, and we get output at the collector. Okay, now you can see that the symbol of NPN transistor is, it is shown. You consider this circle. Look at the arrow. Now the arrow is outward. If the arrow is outward, it is NPN transistor. In the previous slide we saw that for PNP transistor the arrow was inward, but for NPN transistor this arrow is outward. And again the same thing, that we apply voltage between E and B and we get current between E and B. So the current in the third terminal is controlled by the voltage in between first and second terminal. Okay, dear students, there are two important equations regarding this transistor. This is called the equation of transistor. Equation of transistor is IE is equal to IB plus IC. I for current, E for emitter. I for current, B for base, I for current, C for collector. What does it mean? It means that the input current, we know that we introduce the current at the emitter. The input current is IE. This current is divided into two parts. Some part of the current is base current and the remaining part is collector current. Okay, let me tell you. Look here, come to this point. For example, I send the current IE. I am sending the current IE in this portion, and for example it is 30 ampere. This is the input current. Clear? Some part of this current will pass through B, making this loop. Clear? For example, it is 2 ampere current. So this current is IB. The current passing through base is 2 ampere. Out of 30, if 2 ampere current goes this way, what will be the remaining current? Definitely it is IC and it should be 28 ampere. According to the law of conservation of charge or current, the input current is divided into two parts, IB plus IC. If you add them up, 2 ampere plus 28 ampere, we get 30 ampere. Clear? This is the meaning of this equation. We can say that the emitter current is divided into two parts. Some part of the current is made base current and the remaining current is collected at the collector. So IB plus IC is equal to IE. Emitter current is equal to the sum of base current and collector current. This is called equation of transistor. This is very fundamental basic equation of transistor. And another important equation of the transistor is the gain. Gain is the ratio of collector current to the base current. We define gain as collector current to the base current. If you remember, I have told you that transistor is the device which amplifies the current, which increases the current. Increase means step up. When we increase the current, this increasing factor is called gain. Gain is actually the increasing factor. It means how much we are going to increase the input current. For example, here input current is for example 2 ampere. If we increase this current from 2 ampere, if it gets 10 ampere, what is the ratio between 2 and 10? We can say that 5 times the input current is increased. The input current is 2 ampere. 2 multiplied by 5 is equal to 10. It means that this current is increased 5 times. This 5, the factor to which the current is increased, it is called gain. Gain means collector current to the base current ratio. This is the main function or main concept of the gain. Gain is the factor through which the current is getting increased. Dear students, there are some important notes regarding the transistor. Transistor has two loops. We know that one left loop and one is right loop. Right, you can see that here in this figure, this is emitter, this is the base, and this is the collector. It means that base is shared with collector as well as emitter. So this is called common base configuration. This is common base type of transistor. The left loop, this loop E and B, this is a loop, it is always kept forward biased, and the right loop CB, this loop, collector and base loop, this portion is always kept reverse bias, whether it is PNP transistor or NPN transistor. I have told you that in the PNP transistor the arrow is inward, and in NPN transistor the arrow is outward. Here again, this loop E and B loop is always forward biased, and collector base loop is always reversed biased. Dear students, these were the topics that we discussed for the transistors and diodes and half wave rectification, full wave rectification. Initially we discussed the electronics, that this is the branch of science in which we study about the response of semiconductor materials to the current. Whenever the current is passing through semiconductor, what is their response? This all comes into the electronics. So that is why this is the main topic, and I would like to wish you all the best. Please do research on it and make your note. Thank you very much.